Welcome and thank you for watching this video presentation introducing the new all-digital model 1656 battery element tester brought to you by STS Instruments. The 1656 tester was designed from the ground up to replace the industry standard model 1652 analog tester. This video provides an overview of the new tester and highlights some of the new features made possible by using digital technology. If you're not familiar with batteries or battery element testers, we recommend you watch one of our other videos on battery basics and battery element test methods available on YouTube. This image shows the front panel of the 1656. From the large color LCD display, it is immediately obvious that this is a more modern look than the old 1652, which used two 7-segment LED displays. Some of the old testers' controls carry over, however, such as the reset and check buttons. There's also still a shuttle knob, but in the 1656 application, the shuttle is not only used to adjust the test voltage level, but also to scroll through menus and select parameters and options. We'll go over each control in a minute, but first let's look at some of the benefits that this new digital tester offers. Using state-of-the-art processor and analog-to-digital converters, the new tester offers the following improvements and benefits over previous generation testers. Greater accuracy and resolution for test voltage programming and measurements alike, improved repeatability for more consistent test results, several digital control interfaces for remote control and production test automation, easier to use menu-driven user interface with full color display. Colors are used to indicate pass or fail result using green or red respectively, reducing operator interpretation errors. A lower profile packaging compatible with EIA 19-inch rack mount format. Additional benefits not listed here are closed case calibration and fully automated calibration for reduced cost of ownership. Let's take a closer look at the front panel. The 1656 front panel contains the following connectors, displays, and controls. On the left, a set of high voltage input connections for the high voltage probes. To the right of it, a 320 by 240 pixel color LCD used to display readouts and highlights. A rotary knob or shuttle that doubles as an added entry key when pushed. It also allows scrolling through menus and incrementing or decrementing parameters and setting by turning it left or right. There are only 4 setup keys which provide access to the most commonly used menus or functions. They are menu to access the main menu, local to take the unit out of remote state, escape to clear an entry or back up to the previous menu, and lock to lock out the front panel. To the right of the setup keys are 6 preset keys. These allow quick entry of test voltages and pass fail or trip levels. There are 3 presets for test voltage and 3 for trip limits. The check button carries over from the 1652 and initiates testing. This red button is lit when testing is in progress. The reset button aborts any test in progress when pressed and clears the last fault condition. This button is green and lit while a test is running. And finally, we have the main on-off power switch on the far right of the unit. To connect the battery element under test, a set of high voltage test leads with auto-retracting tips are included with each tester. These leads are the same as for previous generation testers. Standard leads are 6 feet long, but 10 feet leads are available as an accessory. This picture shows how to properly use the test probes to test the battery element. Note that both operator hands are required to ensure the operator cannot touch any exposed high voltage. Here is a view of the back of the 1656 tester. From left to right, we find the universal IC line port input, a standard USB interface, a buzzer that sounds when a fail condition occurs, an optional RS-232 or RS-485 serial interface, and the PLC interface. For automated test applications, a rear panel connector or RPC option is available, which allows test leads to be connected at the rear panel. This is shown on the far right. Just to reiterate, the 1656 comes standard with a fast USB interface to connect to a PC for remote control operation. The command syntax uses the industry standard SCPI protocol, which stands for Standard Commands for Programmable Instruments, a widely adopted protocol for test instruments. Thus, if you are a programmer, you probably are familiar with most of the 1656 commands already. Customers that need to control the 1656 from a PLC controller can opt to add an RS-232 or RS-485 serial interface. The command syntax is the same either way. The remote control interfaces can not only be used to control the tester, they also allow test results to be collected on the computer for reporting, tracking, and quality control purposes. The USB interface also serves to calibrate the unit without having to open the top cover, as there are no analog pots or other adjustments inside. Another feature of the 1656 is the PLC interface. This interface contains several relay outputs used to indicate test results and test status, as well as some digital control inputs like remote test and remote reset that allow control from a programmable logic controller. The PLC interface supports integration of the 1656 tester into an automated battery production line. For existing customers that need to transition to the 1656, we also offer a bench model that is functionally equivalent to the rack mount 1656 but closer in size to the 1652. If you're in this situation, please contact STS Instruments to discuss your needs. Thank you for watching this video presentation. For more information on the 1656 battery element tester, please contact STS Instruments or visit our website at stsinstruments.com. You can also reach us by phone or email as shown here.